The purpose in this video is to walk through things to check when you're doing data preparation. So let's start here. We have this data frame. You've seen a similar data frame before, and I can open it up over here. You can see it has this ROA, RDA, average total assets. It's for multiple years and multiple companies. The first one is we saw there are many missing values of research and development. And so RDA is missing here. So if I go over here, notice we have lots of missing. XRD is missing, is research and development. So that research and development expense is missing. So our RDA column has lots of missing values. So the first thing we can do is we could delete those missing values if there aren't too many. So drop NA, I'm going to remove those. Going from the DF data frame, creating a new data frame, TMP, which I call temp. We can look over here then. We have a data frame, the first one, 213,000. The new one is 102,000. So, about half of the observations are removed when we remove the missing values. Typically, losing half your data is not something that you want to do. So maybe that's not the best thing. The next option is to replace missing values. So here I'm going to replace missing values with 0 under the idea that the reason that it's missing is because the data provider just didn't capture it. This may or may not be valid, but it is one option. So here I'm going to create a new column. I'm going to call it the same thing, RDA, even though it's creating a new column. Set that equal to, and then this logic step here. So if else, meaning if it fulfills the first condition, then do something. If it doesn't, then do something else. So exclamation point means not. So not is.na means, so if it's not is missing, so meaning it is, if it's not is missing, meaning it's not missing. So if RDA is not missing, then do the first thing, which is set it equal to RDA. That's the column that's already there. If it is missing, then set it equal to 0. So I'm going to do the same thing. Start with DF, create a temp data frame. Excuse me. So I can open this, look over here. Notice RD is missing, but now in RDA, I have a bunch of zeros instead of the missing values. Next, I could replace the missing values with something else. So here I'm just going to use the median. So here I have the industry and the year. So group by that. So do the calculation for each of those groups. Mutate is create, work with columns. So I'm going to create a new column, MD RDA, which is my way of saying median RDA, which is just the median value of RDA when removing missing values. I'm going to create this new column, then I'm going to do the same sort of thing as I did above. So create a column RDA, if else, meaning if it's not missing RDA, then set it equal to RDA. Otherwise, set it equal to the median RDA. So I can run this. And look in here, you'll see still a lot of zeros, but I go down a little bit and you'll start to see, now notice it starts to pop up. Even though it was missing over here, it starts to have some slightly positive values. It's going to fill in with the median value. All right, now let's turn to some outliers. So let's first do the first thing. You can transform values. There are lots of different transformations. The most common is probably the natural log. So first, let's plot this average total assets. We're going to do a histogram of that. So you can see down here, it looks like one large clump here. That's just because there are a few really large values out here that you can't see. So this means it's a very skewed distribution. So one way to do it is do the natural log. So in R, log is just the natural log. So create a new column that is the natural log. I can plot the same thing, but now doing the natural log. And notice what it has done is take the really large values and squish them in. So there was a lot of values there that are not just zero. So that would help reduce the influence of very extreme values. Another option here, you have the ROA has extremes on both sides. We've seen that before. So what does that look like? If I do a histogram, I can't see the extremes really. So what can I do? Well, so deleting them, I'm going to calculate what an extreme is. So this ROA high, I'm going to take the 99th quantile. So this is like a mean or a median, but it's doing the quantiles. This is the 99th quantile. This is the first quantile or percentile. Let's first look at these. So if I open this, I can see at the end, this is the 99th percentile. This is the first percentile. So it's the almost largest values, almost the smallest values. And then I can only keep those that are between those values. So this is filter, meaning keep whatever the conditions are between, take ROA between the low and the high values. So I can run this. Now notice I lost some observations over here. I went from 213,000 down to 209,000. That's because I deleted a bunch of them. I can create an ROA that is with the new data set that removes those outliers. And notice it looks like something that is not quite a normal distribution, but it doesn't have those outliers in there. Well, maybe we don't actually want to delete those. That's called Windsorizing. So we've already seen the extremes. So Windsorizing would be, instead of filtering here, I'm still calculating the high and the low. And here I'm going to do this if else thing. So if ROA is greater than the high, set it equal to the high. Otherwise, set it equal to ROA. Then the same thing, if it's less than the low value, set it equal to the low value. Otherwise, set it equal to ROA. So same thing, run that. I can check here the histogram. And you'll see what happened is I have a little too many at each end here. That's because the ones that were furthest out were pushed in to be at this point. All right, final thing, I can standardize the values. So this is really helpful when I have different variables that I'm interested in. Here we're just going to look at ROA, but let's say you had multiple variables and you wanted them to be comparable, then maybe you would set them to have the same standard deviation and mean. So we already have seen ROA. This is this Windsorized one. How you would standardize it, or one of the ways to standardize it, I'm going to take ROA, subtract the mean, divide by the standard deviation. Same functions we've used before, or type of functions. Going to create a new column, ROA STD for standardized. And I look over here in the data frame. At the end, I've got this new column, and it's different than this ROA over here. So I can plot this. There we go. So now we're going down to -4 and up to 2. And if you remember with some elementary statistics, if it's more than a few standard deviations away, that's what we might consider outliers. So we still have 4 standard deviations away below, 2 standard deviations away above. That's not quite as much of an outlier, but we have outliers here at the bottom. But it's better than it was. All right, so then what you can see, I think, from some of this is you need each step you make an adjustment. You have to go back and inspect. There are reasons to be careful about it, as you'll see in the mini case for this chapter. And there's not an exact science in this. The main thing is to be careful, maybe try multiple things, and make sure that whatever you do is sort of robust to whatever you try.